Hey guys, welcome to today's video. In today's video, we're going to look at a Leetcode problem, and the problem's name is difference between ones and zeros in row and column. So in this question, we are given a m into n binary matrix called grid. So this is the input given to us, and we need to calculate a difference matrix of the same length m into n by following these rules. So you calculate the index inside a difference matrix using this formula: 1 rows, 1 columns minus 0 rows minus 0 columns. So how are you going to calculate 1 rows is that you count the number of ones in that ith row, and you calculate 1 columns by counting the number of ones in the jth column. You count zeros row by counting the number of rows in the ith row, and you calculate zeros calls using the number of zeros in the jth column. Once you get these 4 values, you substitute each of them inside this formula: 1's row plus 1's column minus 0's row minus 0's column. This will give you one index inside the difference matrix, and you have to do for all the ij's, that is all the positions inside the difference matrix of size m into n, which is of the same length as input matrix. And finally, we have to return that. Now let's take a look at the example 1. So this is the input given to us, and we have to calculate this as the output. So we calculate each of these values present inside the diff matrix. So 0, 0 is calculated by, there are 2 ones inside this. So number of ones is 2. The number of ones in this column is 1. So these 2 gives you the value 2. So 0, 0 of diff is calculated by number of ones inside that row. Number of ones is 2. The number of ones in this column is 1. The number of zeros inside this row is 1, and the number of zeros inside this column is 2. So this gives you 0. That is why this value is 0. Now this is calculated using counting of the same row for number of zeros and number of ones. So this will be same. So this again gives you 0. That is why this value is 0. Now let's see how we are getting 4 here. Here number of ones in that row is 2 plus number of ones in that column is 3. Number of zeros in that row is 1. Number of zeros in this column are 0. So this gives you 5 minus 1, that is 4. That is why there is a 4 here. So add the ones in the row and column and subtract the zeros in the row and column. So that is the formula. You have to repeat it for every position inside the matrix. And finally you get the difference array. So you can see that for every row there will be either one repeating column or a repeating row for which we already computed the values. So for that we will use a array to count the number of ones in that row, and we'll use an array and you know the number of rows and columns. So there is no need to calculate the number of 0 in the rows and number of 0 in the columns. So this can be calculated by total number of rows minus 1 rows. So these are arrays, 1 rows array, that value, and this will be calculated by total number of columns minus 1 column's value. Now we have the 4 values and we can substitute in this formula. So I just use this formula. So this is number of ones in row and number of ones in column, and this is calculated by rows minus, which is a fixed value, minus number of ones. This will give you number of zeros, right? Because here, as you can see, in this row there are 2 ones and the total length is 3. If this represents ones and this is the length, the zeros will be represented by length minus ones. So length is 3, one's value is 2, so this will give you 1, which is this. So there is 1 0 and 2 ones inside this. So that, and this is also calculated using the same total number of columns minus this value. Now let's implement these steps in a Java program. So this is the input, right? And this is the output. So coming to the code, I'm calculating the number of rows and the number of columns, and I'm declaring the output, which is a 2D matrix of size m into n. So it will be of the same size as rows into columns of this grid, in which is input. And I'm creating the 2 arrays because we need to pre-compute a number of ones in that row and the number of ones in that column. So we are using 2 arrays. And there is no need to create 2 more arrays for calculating the number of zeros in the row and number of zeros in the column. We can subtract the total number of rows minus these values to get the zeros in that respective row and column. So I'm iterating through a nested for loop and I'm calculating one row and one column. So let me declare that. So here if I take the same example, this is a 3 by 3 matrix. So m into n. So number of rows is equal to 3, number of columns is equal to 3, and diff size will also be 3 by 3. So this will also be of size 3 and this will also be of size 3. So let's iterate through input matrix here. Starting from 0, 0, we start with this and we move in this direction. So first we start with this element. There is no need to do a if check to check if that current element inside this grid is a 1 or not, because we are adding the number of ones and this is a binary matrix which will contain either 0 or 1 in that position. If it is 0, it won't be added. If it is a 1, it will be added. That is why there is no need to place a if check to identify if that current element is a 1 or not. You can also add this if check to identify if the current element is 1, only then you have to add. But since this is a binary matrix, only ones will be added to this array. So here it is not a 0, it won't be added. It will go here, it is a 1, so 1 plus, and next again it is a 1, so 1. So there are two ones, and here it will check, so 0 plus, 1 plus, 1 plus, and in the next iteration I will become 1. The next iteration again it will count for this values, it is a 1, so add 1, it is a 0, it is a 1. This 0 won't be added, again it will give you value 2, and here it will again check if it is a 1, yes it is a 1, it is a 0, and here it is a 1, and when I is equal to 2 again it will check 0, 0, 1, so it will be 1 only here because in the last row there is only 1, and in this column also it will be plus 0 plus 1. So this will give you the value 1, this will give you the value 1, and this will give you the value 3. So now we have the array ready. Now we have to calculate this formula which is already mentioned here. So let's fill the difference array which is initially of the size 3 by 3. So here 2 plus 1 minus rows is 3 minus 1 row of 0 is 2. So this is 1, and here columns is 3 minus 1 row of columns is 1, which is 2. So this will be minus 1 minus 2. So 2 minus 2 plus this will give you the value 0. And in the next iteration we calculate again. Next iteration I is 0 and j is 1. So 0 is this, 2 plus 1, columns of 1 is 1, minus, again we calculate 3 minus ones of 0 is 2, and this is 3 minus columns of 1 is 1, so this will give you 1 and this will give you 2. So again minus 1 minus 2, and again the entire value is 0. And let's calculate again. I is 0 and j is 2, 0 is 2, and this is 3, and this 3 minus 0 is 2, and 3 minus columns of 2 is 3. So this will give you 1 and this will give you 0. So minus 1 minus 0. So 5 minus 1 is 4. And we start a new iteration. I is 1 and j is 0. 2 plus j is 0, right? This plus 1 plus 3 minus columns of 1 is 2. And again 3 minus 1's column of 0 is 1. So this is 2. This is 1. So this will give you minus 1 minus 2. The entire thing is 0. Now let's calculate again. J will become 1. I will remain same. So 1 of 1, 2 and 1. 2 plus 1. And here 3 minus 2. And here 3 minus 1. This is 2. This is 1. So minus 1 minus 2. The entire thing is 0. Let's calculate again. J will become 2. I will remain same. So of 1 is 2 plus j is 3 minus 3 minus 1, which is this 2. Again 3 minus j is 3. This is 0 and this is 1. So minus 1 minus 0. So entire thing will give you 4. Now let's calculate again. This is 2. This is 0. This is 1 minus plus 1 minus 3 minus 2 1. This is 3 minus also of 0 is 1. So this is 2 and this is 2. So this is minus 2, minus 2. So 2 plus minus 2 minus 2 is minus 2. Let's repeat. J is 1. 1th row of 2 is this 1 plus 1's column of 1 is 1. So 3 minus 1 and 3 minus 1. So this is 2, this is 2, minus 2, minus 2. So this will give you minus 2 again. Calculate again the last cell. J will become 2, I will remain same. So 1 plus 3. So this is 3 minus 1, which is 2, and 3 minus 3, which is 0. So minus 2 minus 0. So this will give you 2. And we reach the end. And finally we come out of the for loop, and whatever is present inside diff, this is present. So this will be returned as the output. So these values are matching these values. So both are same. And this is how the output is formed. So the time complexity of this approach is O of m into n, because we are iterating using nested for loops through rows and columns of the entire input grid. And this is the optimized approach. And the space complexity is O of n, because we are using two arrays to form the output, where n is the length of the matrix, which is the number of rows. In brute force approach, you have to calculate the number of zeros and number of ones for every row and column for all the positions, all the 9 positions. So there is a lot of repetitions. To avoid those repetitions, you are using a pre-computed array, and from these two arrays you are creating 2 more arrays, and from that you are calculating the number of zeros values in those rows and columns using the total number of rows, because this rows and columns is a fixed value here. For this input it is 3 by 3. So 3 minus the length of these two, or the values present inside these two, will give you the number of ones. So I just used the formula given to us in the 5th point. So I hope you understood the problem. That's it guys. Thank you for watching, and I'll see you in the next video.